friends, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. We have got ourselves a pretty jam-packed episode this week, and I wanted to address something that, in case any one of you out there was curious how I've been enjoying all of my newfound free time, and if I'd be able to keep myself busy or not, rest assured that I am loving life right now and have been extremely productive in my personal projects, as you've probably noticed with how large and lengthy the past and future nerdy things segments have been. And after all, I did challenge everyone at the beginning of this year that 2024 is the year of the personal projects, and I'm not sure about you, but I am doing pretty good at keeping to that challenge, so hopefully you are as well. So yeah, don't worry about me. I am very much enjoying all of my extra free time. But with that, let's get into our trivia question for the week. And this week's trivia question is, what term is used for the most basic level or core of an operating system responsible for resource allocation, file management, and security? Is it A, the BIOS, B, the terminal, C, the bootloader, or D, the kernel? So that was A, BIOS, B, terminal, C, bootloader, or D, kernel. And that is your trivia question for the week. So guys, Vision Pro is officially here. And as of the recording of this episode, it's still technically not even out yet, since I am recording this on February 1st, and Vision Pro, of course, comes out on February 2nd, and this episode goes live February 3rd. So there's a chance that you know more than me right now. Pretty much all of my knowledge comes from watching MKBHD's unboxing and initial impressions, I guess, videos. He did two of them, at least as the recording of this episode. So that's pretty much what I'm going off of for this. So we might revisit this next week once I've seen a little more of what other people have to say about it. But at least initially, it seems like it's going to be pretty darn cool. Now, I will say, the biggest bummer, I think, for me about it is you're paying, you're paying at minimum $3,500, not including tax or shipping or anything like that. But you're paying $3,500. And you can't even get dual screens on the thing. And by dual screens, I don't mean multiple, Vision Pros, obviously. But I mean when you connect to your Mac, for instance, you can only get one screen for your Mac. You can't have two, make your Mac that you're, I guess, screen sharing or whatever. You can't make two, virtual screens. You only get the one. Now, on the one hand, this isn't a huge deal, I guess, because again, you can resize that screen to be however big you want it. So in that sense, you could essentially make it take up the real estate of multiple monitors. But on the other hand, it's not multiple monitors. And I don't know about you guys, but me as a developer, I pretty much need to have at minimum two monitors. Of course, you have your one monitor for your IDE or your code or however you're doing your editing, and then you have another monitor for web browsing documentation or something like that to do research on what you're trying to code. Or maybe you're working with a GUI application and you have the other monitor for rendering that and viewing that and testing it and that kind of a thing. So as a developer, having multiple monitors and tons of screen real estate is definitely a must. So that was, I guess, the big, downside, if you will, for me. But like I said, you can kind of counteract this in a couple of ways. One, you could just make the screen a heck of a lot bigger because you can resize it to be however big as you want. But the other thing you can also do is, even if you are virtualizing your Mac's display in the Vision Pro, you can also run standard Vision Pro apps alongside it. So you essentially could get the functionality of a dual screen monitor, or two screens rather, and you have like your Vision Pro app for Safari open on the left or on the right, or however you want to orient it, and then the other one is your Mac's display, so you can kind of sort of get two monitors out of it that way. So there is definitely ways around it. But the other cool thing too is, once you connect your Mac, you can use the trackpad and keyboard from your Mac, or mouse, I guess, if you're using a mouse, to control the Vision Pro as well, which is definitely a nice feature there. And this, I'm saying all this I've tried it out, which I haven't. I'm just basically going off what the 1 MKB HD video that I saw. But the one thing that I guess kind of stuck out to me about that was the whole persona thing, which, if you're not familiar or don't remember, it's basically how Apple will make you be included in FaceTimes, and there's other things you can do with it too. But it's essentially a digital representation of you. So basically how it works is you have the Vision Pro essentially scan your face in a couple of different facial expressions, and it walks you through a whole thing. And the thing that's really interesting about it is, well, first off, it's in beta, and I'll just say that the fact that it's in beta pretty much just sums it up. But the thing is, it looks really cool, but also unrefined at the exact same time, and it's really hard to explain. Like, it seems like it's able to track you really well. Like, it mimics your facial movements pretty darn well, and as far as like how you look, like how much the persona resembles you, it's kind of like you, but also like you're in a cartoon or a video game or something. Like, don't get me wrong, it definitely resembles you and looks like you, but if you put like your persona and you side by side, you could pretty obviously tell that they're very much different, and the persona looks a lot more digitally generated and cartoony, if you will. So, but at the same time, like, it tracks all your movements really well, and it's really weird. I definitely, well, some of you, most people that actually pre-ordered the thing have gotten it, so I'm assuming by now there's probably a lot more other reviews out there and people talking about it. So I definitely encourage you to look into some of those. If you think whatever I'm saying sounds absolutely crazy, or it's just not making sense, definitely go and watch one of those videos where they break it down. But yeah, Vision Pro is here. I do not have my hands on one, and quite honestly, I don't have $3,500 burning a hole in my pocket, so I don't exactly plan on getting one anytime soon. But it definitely looks pretty darn cool, and I don't know, maybe come like some generation down the line, I don't know how many, when the price actually becomes more realistic, I might end up picking one up. Or I might go to my good old friend eBay after it's been out for a few years and the prices have come down. I don't know. But the weird thing about that, I guess, is there's so much like custom fitting for the Vision Pro that I'm really not sure how the secondhand market is going to work for Vision Pro, because in order to get one, you essentially have to like scan your face or like go into an Apple store for a fitting, and it basically, orders you custom parts, but I put that in quotes because I'm pretty sure what they're doing is they just have a select range of sizes, and then based on like your facial scan or whatever, it like puts you into one of those size groups and then does it that way. But it's not like a one size fits all thing, which I guess makes sense because this thing's going on your head. Everyone has different head sizes. So it's not going to be like a Mac, for instance, where you just look for the specs you want and then you buy it. Like it's going to be a different process on the secondhand market. And I'm really interested to see how that pans out in the coming years. But I guess we will find out. But with that, let's get into this week's cybersecurity tip. So you can add another tally in the, I don't know why I have to make this a cybersecurity tip, but here I am, because apparently what I believe to be common sense is apparently not all that common, because I was walking around this week and I was walking through the parking lot, and I, as you do when you walk through the parking lot, looking at all the cars and everything, and I happened to peer through the front windshield of this one car, and I saw one of those, like, I'm pretty sure it was like it was either a dashboard mount or like one of those vent clip mounts that like you either put on the dashboard on a vent and it kind of like holds your phone in place, so it's like kind of like off in your peripheral vision, so you can have it as like a navigation thing or whatever. So I saw one of those, and there was a phone in it. I kid you not, there was an iPhone something Pro, I don't know which one, but it had the 3 cameras and like the triangle shape, so I knew it was a Pro model. I didn't know which one, but there's just an iPhone just chilling in there. Nobody inside, no driver to be seen, no one else in the parking lot that I could tell. So I was like, man, this guy or gal has some serious, they got some serious something to be to have, I guess, the courage to just leave their phone for all the world to see right there in their car. So I think it goes without saying that you shouldn't do that. But it's not just like for phones and electronics, but any kind of valuables. You just shouldn't leave those, visible in your car. And like I said, I thought this was just something common sense, but apparently not. And, the best cybersecurity in the world, is not going to protect you from, say, someone stealing your phone and getting access to all your personal data. It doesn't matter how, secure you are, because cybersecurity is a lot more than just, firewalls and encryption and all that stuff. Physical security plays just as big of a role, if not a bigger role, when it comes to cybersecurity. Because if you leave your electronics unattended, yeah, I mean, in theory, you should have your devices encrypted, and I'm pretty sure iPhones are encrypted by default, but they're only, like, fully encrypted if they're, like, either powered off or have just been powered back on but haven't been unlocked yet. Otherwise, you can, get data off of them. But it's the same thing with laptops and whatnot as well. Like, yeah, you can have encryption on them, but if you have the device on or in like a sleep state, the drive isn't going to be encrypted. So once you boot the thing up, part of the boot up process is, decrypting everything so you can actually, use the computer. Don't leave your electronics unattended like that, because if someone does get access to your, computer or your laptop or whatever, and you did happen to not have it, fully locked or shut down or whatever, and they get access to it, well, I don't know what to say. Like, you can kiss your identity goodbye. That's probably going to get stolen. If you have the device, you gave it access to like your home network through like a VPN or something, they could now get into your home network and do whatever they want, ransomware everything, steal even more data, run a bunch of crypto miners on all your hardware. The sky's the limit, basically. So yeah, don't leave your devices unattended. And I guess the other little tidbit I'll throw in here is if your device, for whatever reason, does get stolen and you say have VPN access on it into your home network or to some other network, you should, as soon as you possibly can, remove that device's access to the VPN. So if you're using like WireGuard, for example, removing the key from the config file and restarting it so if they do try to connect, they're not going to be able to get in. And basically really got to ensure that anything that device had access to, you revoke that access as soon as you can, to make sure that if anyone is trying to do something nefarious with it, they can't, or at least try to prevent it as much as possible. So yeah, that's your cybersecurity tip. I didn't think I would be using this as a cybersecurity tip, but apparently there is a non-zero number of people out there that needed this tip. So that is your cybersecurity tip for the week. Now, before we get into some of the nerdy things that I got up to this week, I did see this one article this week, which I kind of thought was a little funny, maybe in an ironic sense, but funny nonetheless. So it's an article that basically talks about burnout in developers, which we had an episode of a while back going over why developers aren't loyal. And one of the big reasons for that is because of burnout. But the thing that I find funny about this article is there was a JetBrains developer lifestyle survey, and it found that 70% of developers out of the developers that get burned out, 70% of them said that they code for fun on the weekends. Which, I mean, that tells me a couple of things. It tells me that, one, the developers are not tired of coding, and what they are tired of is either what they're coding, how they're treated, or the culture at their workplace, or some amalgamation of that, or potentially something different. But the fact of the matter is, they're not tired of coding, because if they were, they wouldn't be coding for fun on the weekends. Yet here they are, 70% of them coding for fun on the weekends. Now, we talked last week about productivity trackers. Maybe their workplace is too focused on those, and they feel like they can't spend as much time making the code better, and they're just kind of focused on hitting all these tight deadlines that it kind of takes the fun out of it for them, at least in their professional life. And another potential possibility is maybe they're on whatever project they're working on, because everything is trying to be pushed to the deadline, and everything's kind of getting rushed out. There's a lot of technical debt associated with whatever project they're working on, and instead of actually being able to fix all of those issues and kind of resolve that technical debt, it just continues to pile on and pile on. And one thing I will say, as a developer, I have been kind of in this situation before where I had deadlines to meet, and needless to say, I couldn't get the code as polished as I wanted it to be. And I have to say, that is a little disheartening, especially when you can't necessarily go back and fix it and get it the way you want it to be or think it should be, because either more work comes, or whatever project you're working on, maybe the funding for it dries up, or you get switched to a different project, or whatever the case is, you can't make the code as good as you think it should be or as good as you want it to be. And that is honestly pretty disheartening and can definitely lead to burnout. But one thing that I touched on in there was technical debt. And if you're not familiar with the concept or the term technical debt, in a nutshell, it's basically the byproduct, at least in the software development world, of rushed development. So rather than, kind of what I was talking about, doing a really good job of writing the code, making it modular, writing functions for things, not having a bunch of duplicate code, making the code really reusable, all the good things that you want to have in good software development. If you really have to rush through the development process, you're probably not going to have as many of those nice to have things like, very modular code, reusable code, that kind of a thing. And because of that, those kind of add up, and that kind of becomes your technical debt, if you will. And the thing is as the project grows and grows, and this hodgepodge of, rushed solutions and Band-Aid fixes kind of mounts, it becomes more and more of a liability and a limitation. And this just, causes a bunch of bugs to crop up because your one hacked together solution isn't really all of that universal. So then there's another edge case that breaks it, and then you don't have enough time to go in and fix it the right way. So then you put in another Band-Aid fix, which adds more technical debt, which then causes you to do more bug fixes. And it's just really not a good solution. And the other thing that can also happen too is you can get really spaghettified code. And spaghetti code is some of the worst code to work with, let me tell you. You got functions all over the place, nothing makes sense, and it's just an absolute nightmare to have to work with a code base like that. So this idea of debt is essentially the future cost of having to rework the code base because the solution isn't adequate. So essentially, you can rush through the code to get it done by the deadline, but again, it's kind of going back to that thing of how good is that code really? I can write code to do a certain task, and as I mentioned when we talked, I guess it was last episode when whenever we were talking about the productivity apps, I mentioned that on the first pass through me writing code for something, it's almost never the final solution that code is in. I almost always go back through and rework things and refactor stuff and reorganize things, optimize things, that kind of a thing. Because at least for me, the first pass through the coding problem, if you will, or trying to solve the solution, is almost always, let me just focus on getting this thing working. And then once I have it working, I can go back through and make it nice and reusable and modular and all that stuff. But if you're rushed to pump out some code by a deadline, you don't necessarily have that luxury. So it ends up mounting as technical debt when your essential first pass solution of just trying to get something working that has a lot of hacked together code, probably has some magic numbers in there, really not well written code, ends up being the production code, and then someone has to come along later and refactor that, and here again comes the technical debt. And if you haven't heard of the term magic numbers, that's essentially at least in programming, where if you essentially either multiply something by something or you assign a value that isn't a variable. So instead of, saying if the array is less than array length, you say is array less than 5 or something like that. That is essentially what a magic number is. And magic numbers are horrible for a couple of reasons. One being, and probably the most obvious, is if you ever change that number, you have to manually go through and change every single location where that number is. So if you're, for instance, we go back to that array length thing. If you're checking the length of the array, and if you're always checking to see if it's 5, however many if statements, for loops, while loops, whatever where you're checking, you now have to change that 5. Whereas if you just set a variable to be like, max array length is 5, then you can just say max array checking against max array length. Then if you ever need to change that length, you just change the variable and everything changes according to it. And that is a good programming practice, but through an initial pass of just trying to get things working, sometimes that may or may not happen. As much as we developers like to pride ourselves on writing good code, every now and then we're just trying to figure out if something's going to work, so we'll throw in a magic number in there, or maybe 2 or 3 or 4, and we'll come back and refactor it later. But if we don't have time to refactor it later, that code then becomes the production code and someone has to deal with it, hence the technical debt. So another thing that can the other thing with the technical debt too is it generally doesn't always happen at once. It's like an accumulation. It kind of slowly grows over time. And the other thing too is perhaps you just thought that this project or this code base was just going to be something really small, but then it keeps getting built upon and expanded out, and things are kind of always getting patched together and really becomes spaghettified because everything is essentially a patchwork kind of all being layered on top of each other, and it just becomes an absolute nightmare and an absolute mess. And then some poor soul is gonna have to come through and refactor that. And that whole like refactoring process of actually going through and fixing the code and doing it right essentially is the paying back of the technical debt. Technical debt is something that is not good. It's essentially unavoidable. But at least as a developer, knowing that it exists and essentially not being able to do anything about it is pretty disheartening and can lead to burnout. So I can see why some developers would feel that way. But at the same time, when it comes to coding for fun on the weekends, you essentially get to determine if the technical debt is allowed to stay or not. Usually, you'd probably elect that it is not allowed to stay. And the one thing that I've found in my years of programming is sometimes, even when I don't actually implement any flashy new features and essentially just spend hours just fixing bugs and refactoring code and essentially changing absolutely nothing about the functionality of the overall program, but just, changing from the code aspect, making it more reusable, putting things into functions, better naming variables, documenting things, that kind of a thing. Something about that, at least to me, is just so satisfying, removing all of that technical debt, if you will. So I definitely can see, why the developers, even though they're getting burned out at work, are still programming for fun on the weekends. But speaking about programming for fun on the weekends, let's get into what nerdy stuff have I been up to this week. So I really haven't touched much on my home lab in recent weeks since I've been so focused on programming projects. So if you're missing home lab content, I'll give you this little tidbit here, since I did do a little bit with it this week. So for the video game I'm making, it uses 2D sprites. And I was kind of doing some research about potentially trying to find some kind of tool that would allow me to, essentially do pixel art or 2D sprites in a more efficient manner, I guess we'll say. And during that research, I found this tool called Sprite, which I'm not endorsing it by any means. Because like I said, I just found it, and I've used it once. But when I was looking at it, one of the things that piqued my interest about it was the project had a GitHub and the source code was available. So I was definitely intrigued by that. But one thing about Sprite is it does require you to pay for it. But the source code's freely available. So if you go through the process of downloading said source code, building it yourself, and just using it, for personal use, then you can use it for free. So that's what I decided to try to do, because one thing, I'm not opposed to buying software or buying things in general. But one thing I generally don't like to do is spending money willy-nilly on something I'm not sure I'm going to like or use. So that's kind of one of the reasons why I opted to go the compile it yourself route. Plus, it's just kind of cool to compile things yourself. Maybe that's just the software developer in me talking. I'm not sure. But anyway, I decided to compile it myself. And I figured that since I do at least the majority of my development on macOS, I would try to build it for macOS. But the other thing I also decided was that I don't want to have to install all these dependencies on one of my Macs just for things to potentially not work, or I realize I don't like the software, and now I have all these random things installed and dependencies that I don't want. But thankfully, I happen to have a virtual machine in Proxmox that I recently set up to be a macOS operating system that happens to function as this exact purpose, to essentially be a macOS sandbox, so I can, test and develop things for macOS and just kind of test things out without having to do it on one of my personal Macs. So I decided this was the perfect opportunity to put that VM to good use, and I decided to develop a script because, of course, I cannot be bothered to have to go through all the steps of installing all the dependencies, downloading all of the packages, downloading all of the requisite third-party libraries, downloading all the source code, compiling everything. I mean, that is just way too much work. So what I decided to do was develop a script that can do all that for me. And the nice thing about having a virtual machine on Proxmox, for instance, is if I mess something up, I can just roll everything back like it never even happened and try it again. So that's what I ended up doing, pretty much rolling it back a few times, testing the script, trying to see if I could get it to build and whatnot. And I did get it to build, got the script working pretty darn good, and I was definitely happy with it. And then it came to actually using the thing, which I gotta say, it is a million times better than what I was using before, which was MS Paint. Yes, I was using MS Paint, which was very brutal, let me tell you. It was not a good time. So this is definitely better than MS Paint, but again, I've only used it once, so I can't, say actually how good it is. But if you're using MS Paint, I can definitely recommend it over that, that's for sure. But as I mentioned kind of a while ago in one of the episodes of, why every developer should have a home lab, this is essentially one of the core reasons, because as a developer, you need to do a lot of testing and experimenting with stuff. And rather than doing it all on your personal machine, you can do it in your home lab on a virtual machine. And then if you happen to mess it up, you don't have to worry about having to, fix your personal machine. You can just roll back the virtual machine to the previously working state and act like nothing actually happened. So definitely another fantastic reason for all of you developers out there to get yourself a home lab. And the other side note I will put in this kind of home lab discussion is you're definitely going to want to stay tuned for next week, since I didn't get around to it this week. But I have a really cool, at least I think it's cool, CI/CD pipeline project that I'm planning on working on. And I'm going to try to get implemented this coming week. So you'll definitely want to stay tuned for that, because I think it's going to be pretty awesome. So now moving on to some of these software development updates for the video game I'm making. So the game I'm making, if you're new, I'm basically trying to make my own Pokemon game from scratch. And one thing that I've been kind of touching on the past few weeks is the whole getting the front end of the battle scene, if you will, connected to the back end. So one of the first things that I did when developing this game was trying to at least get a prototype, if you will, of the back end function of a battle. And I got that working fairly decently. It obviously wasn't fully complete yet. You can only use attacking moves, but again, who doesn't use only attacking moves, if we're being honest? Well, I guess a lot of people, but I know at least when I was growing up, if the move didn't deal damage, it was essentially worthless. So younger me would be absolutely find no faults in how the battle was before. But I wrote that a while ago. But that code was only executable through the command line. And obviously, video games in general, at least modern video games, tend to have a graphical user interface, or a GUI, which is a visual representation of what is going on, and not a, text-based version. So while the battle worked, it was not very aesthetically pleasing, if you will. All just, you'd enter what move you want to do, and just a wall of text appears of everything that happened. So obviously not ideal and not like the real thing. So I've been trying to work on integrating the two, the back and the front end, together. And I had gotten most of it working, but there were still kind of a couple minor things that weren't working yet. And I managed to get most of those knocked off this week. So the first one being damage. So before, I had damage working in the sense that at the end of each turn, your damage would be reflected by how much damage you actually had left. The problem was, as soon as you clicked what move you want to do, all of the damage you would accrue during the turn and all of the opponent's damage they would accrue during the turn automatically fully appears all at once. Which, if you've ever played Pokemon before, that's definitely not what happens. Or if you've played any kind of turn-based game in general, that's not what happens. So that was kind of one of the goals I had, was to get that damage animating, which I was successful in getting that accomplished. So now when you do an attack, that damage gets dealt, and then if you say accrue recoil damage, that'll get dealt afterwards, and then if you have like some kind of status condition damage, that'll get dealt even after that. So it all kind of gets dealt when it's supposed to be, and animates the bar going down and the HP value going down. So that was a big win. The other big win was I procedurally generated logos for the types and status conditions. Now, I use that term fairly loosely in this context, because generally when it comes to procedurally generating graphics, you kind of think of procedurally generating a map, or essentially, here's a set of tiles. I'll put this through an algorithm and it'll create a map, which we'll get into that a little bit more. But going back to my implementation, the reason I use the term procedurally generated is the logo for like the status condition, for instance, is it has like an abbreviation of the status condition with a colored background. So the way that I guess procedurally generated, if you will, is every single one of the types and the status conditions in the game, I assigned them an enum. And basically what an enum is it's an enumeration, or basically a way of giving numbers names. So rather than, checking to see if the type is equal to 8, 3, or 10, I can check to see if the type is equal to a human readable value, essentially a variable name, if you will, to check against. So instead of saying if type is equal to 8, I can say if type is equal to ground, which is a lot more human readable, not having those magic numbers like we talked about a little earlier in the podcast. So great for human readability and great for, just readability of the code in general. So I essentially wrote two functions for this. One for the types and one for the status. And thanks to the enums, all of the types and the status conditions have numbers assigned to them. So basically what I can do is I can do some simple math based on if I'm trying to get the logo for the type or the status condition, and get the exact dimension and location on the sprite sheet that contains all of the types and status conditions, and pull out only the one I want and display it properly. So that's why I say it's procedurally generated, since I'm technically generating which logo I'm getting algorithmically by, given a value, given A, I output B, that kind of a thing. And the reason why this is so cool is I don't need to, because initially you might think, well, if I have all the different types, I can just do like a switch statement or something based on the type. I can do, this specific calculation to get this type, or this calculation, or this one, or this one, or this one. And that would definitely work. And you could also make it a lookup table too, where you essentially have a lookup table, which would, I guess, be a rectangle, since we're talking Raylib world, and you basically have a rectangle that's associated with where on the sprite sheet the type or status condition you're trying to get is. So you could have an array of the rectangles that would correspond with the index of the type or status condition, and you could do a lookup table that way. But that's just a lot of extra code, right? Like, you're hard coding all these values, having a massive switch statement in there. So having just two simple functions that I think amount to around 12 lines of code to get every single type, which I believe there's 18, and every single status condition, and the amount of types and status conditions is more than the amount of lines of code I wrote to get them all. I mean, chef's kiss right there. Beautiful. So what exactly is this math operation? So how the sprite sheet is designed and laid out, which is actually how the first use of Sprite I used, because I downloaded the one from, I think it was, there's a sprite sheet resource online. I forget exactly what it's called, but they have sprite sheets from a bunch of, I hate saying this, but old video games. So I pulled the one for Pokemon Emerald, which is kind of style-wise what I'm trying to base my game off of. So I pulled the sprite sheet down, and of course, that sprite sheet doesn't have the fairy type, which I decided kind of begrudgingly, I guess, to add. But I decided to add it anyway. But it obviously didn't exist in that previous sprite sheet, so I had to add it. And also, rather than having to change a ton of code, I decided to modify the sprite sheet to order the types to match how I have them ordered in my enum. So that's essentially what I used Sprite for, and for that it worked pretty good. But anyway, getting back to how the math operation works. So based on the sprite sheet, I know a couple of things. I know how many rows and how many columns there are. So what I can do is I can take the total size of the sprite sheet and divide the width and the height by that number of rows and columns to get, the number of logos that I need. So then once I have that, I can just do a simple division and modulo operator to calculate the X and Y position. So because I'm dividing the overall dimensions by the number of rows and columns, I can identify how big each one of those cells, if you will, that corresponds to the logo of the type or status condition is. And then in order to find the X and Y condition, I essentially just divide by the type, for instance. So let's walk through an example here real quick. So the dragon logo, for instance, is, let's say it's at row 2, column 3. And of course, we're starting at 0. So if you really want to think of it in human readable terms, that would be row 3, column 4. But because this is the computer science world, everything starts at 0. So it's row 2, column 3. So in my enum for types, dragon is 14. So in order to get the X and Y location for dragon on the sprite sheet, we first divide 14 into 2. We need to convert it to the X and Y values, right? So to do that, we need to figure out 14 into 2 and 3. So for the X value, which we established is 2, it's row 2, so that's the X value. What we do is we take the type, which is 14, and then we take the modulo of that number to give us of the number of rows, which in this case on the sprite sheet is 4. So 14 modulo 4 is 2, since 2 is the remainder of 14 divided by 4. So then, you guessed it, to get the Y, we take the result of 14 divided by 4, which gives us 3. And yes, technically it's 3 point something something something, but because we're in C++ world, we're doing integer division, so everything after the decimal just gets cut off and we're left with 3. And if you'll remember, we got 2 for the X by dividing 14 by 4, the number of rows, and then 14 by 4 again, 14 modulo 4 to give us 2, which is the row we want, and then 14 divided by 4 gives us 3, which is the column we want, which is the exact X and Y location for the dragon type. So then that's essentially the math operation we do on every single type and status condition we get. We just do that simple math operation and we get the exact X, Y location. We already established the width and the height for it because we know how big the sprite sheet is with how many rows and columns. So just like that, with some simple math, we're able to procedurally generate exactly the logo and column we want from the sprite sheet given the input. So that was pretty awesome. Now, to put into some more perspective why it's so awesome, we can first look at, first off, how efficient it is, essentially just giving the type and it can spit everything back out. But also, imagine we were doing a lookup table, which would probably be the second most efficient way to do it, assuming we don't use any kind of bit packing or some other shenanigans of using a smaller data type, because then we just have to convert it to a rectangle anyway. If we just assume we're using a rectangle in Raylib consists of 16 total bytes because a rectangle consists of 4 floats, and a float, at least in a 64-bit architecture with C++, is 4 bytes. So 4 of those, 4 times 4 is 16. So the theoretical lookup table for all of the types and status conditions would cost us 400 bytes worth of memory, whereas our procedurally generated solution costs us nothing. Now, you're probably thinking a couple things. First, 400 bytes really isn't that much in the grand scheme of things, which you're absolutely right, it's not. But as we mentioned a while back when I was going on a massive rampage, essentially redoing all of the code and all the classes and trying to optimize for space and whatnot, while yes, a few bytes here and there isn't much, once you scale it up to the size of having tons and tons of these things, 400 bytes here, 200 bytes there might not seem like much, but once you compound that over a bunch of iterations, it adds up pretty quickly. Now, granted, in this case, it would just be 400 and would always be 400 bytes. But if I took that same mindset for every single instance of, oh yeah, this is only 200 bytes, it's only one instance, no big deal. Oh, this one's only 600 bytes, but it's only one instance, no big deal. If I do that over and over again, all those instances of it's no big deal kind of add up to be a big deal. So that's one reason why it's pretty big. And the other thing you might be thinking and could argue is I still take up 16 bytes because I'm returning a rectangle as a portion or as the return value of this function. And that is true, but that's not necessarily any additional space that the program needs to take up initially for its memory footprint. So whereas if you made a lookup table, that lookup table would have to be in memory in order for you to access it. Whereas my solution, there is no 16 bytes, just allocated in memory for the duration of the runtime of the program. It just is calculated on the fly and used when needed and then freed. So that's one very nice thing. So yeah, as you can imagine, I was pretty hyped about this to get that part working, and also having it work, for the status to correctly appear and disappear when it's supposed to was absolutely fantastic. But going back to procedurally generated stuff for a second, I mentioned that while it's technically procedurally generated, it's not procedurally generated in the sense of what people normally think. So the true sense, if you will, of procedurally generated graphics would be you, instead of designing like an entire level or an entire dungeon or something like that, you essentially have an algorithm pick assets that fit together and make the dungeon or map that way, which I do intend to do at some point, but we're kind of a little ways away from getting to that point. But I do plan on doing that. But essentially, true, if you will, procedurally generation would come from something like a wave function collapse algorithm or some kind of cellular automata or something like that, where essentially you would give like a random element, set some random value to be something, and then you would have the algorithm go through and randomly pick tile sets to try to line them up. And basically how this works is you assign keys to each side of, say, the tile set, and how the algorithm is able to determine if two tile sets can fit together is if the sides of the tile set that line up, so if you think the top of one tile set has to line up with the bottom of another one, if the top of the one and the bottom of the other have keys that match, then those tile sets can go together and you can build it that way. So essentially how these algorithms work is essentially checking to see if those keys match, and if they do, add them and just generate the map that way. And the way you can do it is like through a cellular automata, for instance, is, things like the game of life, for instance, basically works on this idea of a cellular automata, where you have a single cell, and then based on the state of that cell and its neighbors, you decide what the next generation's going to be. So you can essentially think of the same thing with trying to design a map, for instance. So you could say if I have a cell which has, say, no walls, this tile has no walls a part of it, and it's neighboring to the top left or the top left and left also don't have any, then in the one below it, there has to be one with a wall. I totally just made that up on the fly, but that's basically what you can think of, where based on a certain number of rules in your current state, you decide what the next one's going to be. Something like that is how you could also do a procedurally generated layout. So yeah. The other thing that I kind of made in the same vein of kind of working with sprite sheets and whatnot is I made a prototype, and this prototype essentially allows me to pull a singular sprite out of a sprite sheet of multiple. And this is different than the logos and status conditions for the main reason of being this prototype essentially is agnostic to anything. You basically tell it the XY location and potentially the size, and it'll spit you back out that sprite specifically, and you can scale it up to take up as many positions as you want, make it as big as you want, and programmatically be able to do all that stuff. And I hear some of you saying that idea of picking a tile out of a tile sheet and putting it down to design the layout kind of sounds like something a game engine would do. And you're right, it is. It is something that a game engine would do.
If I had one!
But I'm using raw C++, baby, so no game engine here. So we're doing it all manually and programmatically, which I guess programmatically is the better term because I'm basically coding it all, which some of you probably think I'm crazy for doing that and not using a game engine, and at some times I would agree with you, but the main reason I'm not using a game engine is because, like I said in the beginning, one of my goals for this project was to do as much of it from scratch by myself as possible. And while game engines are fantastic for making your life easier, they also generate a lot of code for you, which the point of this project is for me to essentially do it all myself. And if I'm having a game engine generate a lot of the code for me, I'm kind of failing at that goal, at least in my opinion. Now, maybe you're trying to make your own video game from scratch and you're letting yourself use a game engine. That is totally fine. I am not bashing you in any way. Just for me personally, I set out as this goal to do everything myself. Now, I have thought about, seeing that I have this prototype that can essentially do kind of what a game engine does, all I got to do is throw a GUI on this thing, and I essentially have myself a mini game engine. And then I would just essentially have to make it auto-generate code for me, which that kind of sounds like its own project. But I some of you are probably also thinking, if you're trying to design this whole thing from scratch, why are you using Raylib? And that is a fantastic point you make there. If you're newer to the podcast, you might have not heard the explanation, but essentially, I was 100% planning on writing my own graphics library to use for this game, and then I realized how much work goes into making a graphics library, and I was thinking, if I went through and made my own graphics library to use for this game, the graphics library would probably be as big of, if not a bigger project than the project I'm trying to do, which is a full-fledged video game. So I allowed myself the concession that I would be allowed to use a graphics library to at least handle doing the graphics, but everything else I would have to do myself. So all of the coding of what the graphics does, all of the loading of assets, all of the moving of sprites and objects, checking for collisions, all that stuff I would be doing myself, which is part of the reason why I'm not doing using a game engine, because game engines, at least in my experience with using them in the past, for the most part, kind of handle all that for you, which, like I said, I want to do as much of this from scratch as possible. So that's why I'm not using a game engine. But speaking of, we've been talking a lot about all the code that I've been writing recently, and we have actually hit, at least what I think, is a fairly large milestone for this project specifically, which is we have officially, and I put that in air quotes, we have officially, or I guess because I'm still writing the code, have officially written over 10,000 lines of code. And the reason why I say officially in air quotes is because that is just the net lines of code that I've written for this project. So if you were to use some kind of source code calculator to calculate how many lines of source code you wrote, which I happen to have written a tool like that, which I used, it will say, over 10,000 lines. But that, as you can imagine, is very, very, very deceptive. Because if you've ever written code before, the lines of code in the file do not account for all of the other lines that you have either deleted, changed, added, and then removed, and then added back, moved to a different file, removed, changed, modified. You get what I'm saying, right? Like all the refactoring you do, all of the rewrites, all of the optimization you add, none of that gets captured in the lines of code that you've written. Like all of the lines of code that I wrote before I went through and overhauled essentially every single one of my classes to make them more optimized doesn't count. All of the lines of code I wrote to fix all of the various memory leaks doesn't count. All of the code that I wrote and then changed is not included. This is just the net lines. If you look at the code as it stands right now, that is what it is, but that doesn't account for all of the lines of code written throughout the course of the project. So if you actually accounted for all of the other lines, we probably hit 10,000 lines a heck of a long time ago, but we are at least officially now over 10,000 lines, which I almost can't say anymore because I did the check to see how many lines of code we were at, and I think it was like 10,100 and something. And then I kind of went through and did some refactoring, because right now, since I have the battle state, the battle scene pretty much working in the state that it's connected as much as it can be with the back end without adding more to the back end, I'm pretty much at the state now where I'm going through and cleaning up some of the technical debt, refactoring the code, making it more readable, making it more modular, all that good stuff. And as a result, the number of lines of code has decreased. So I think the last time I checked, I think I was literally less than like 20 or 30 lines away from being below 10,000 lines of code again. So I essentially managed to strip out over 100 lines of code just through refactoring and updating the code and making it more readable and all that good stuff. So, just doing something like that can essentially take away from your total, which wouldn't be included in the overall lines of code written. So that's why I say the net lines of code is just over 10,000, but in reality, it's probably a lot more than that. But the reason why I say this is a milestone for me is a couple of things. First off, it's 10,000 lines of code. And second off, this is hands down the most lines of code that I've written for any project throughout my total development career. I think even professionally, I've definitely written a ton of lines of code professionally, but I don't know if I've written 10,000 lines, at least for a single project. I'm not sure, although I haven't really ran a calculator to check. But in any case, personal projects, 100%. definitely the most code, hands down, that I've written for a single project. I think the second one that comes close was, I want to say, somewhere between 6,000 and 7,000 lines, but that's also deceptive for a different reason, because that project was essentially a Java program that was an amalgamation of a bunch of other programs that I wrote also in Java. So essentially what it was I called it an operating system, which it obviously wasn't. But essentially what it was a way that you could log into a system, essentially, and you would have a quote-unquote desktop, and you would have a start menu, and from there you could do things like update settings for the app. You could access like an app drawer. You could change your password. You could check email. Yes, it had email, which was the thing I was probably most impressed by. My biggest achievement for that project was I essentially created an internal email system. Now, not to get too off topic, because we're already kind of running long on this episode, but a brief summary of how that email system worked was it only worked internally, so I couldn't send an email to an actual email address. I could only send an email to another account on the same program, because how I was saving emails was essentially serializing everything to a singular file, so every single email that everyone would send would just get written to the same file. I wrote it a while ago. I'm not trying to say that this was the perfect way to do this, because looking back, it was a pretty terrible way to implement it. But it worked, and it was definitely really cool. But that project also had like other programs that I had written previously that weren't specifically for that project. So previously I had written a snake game, which I included that in the source code. I had written a Pong game that was included in the source code. I wrote a calculator that was included in the source code. So there were other like games and stuff that I had written previously that were completely separate from this quote unquote operating system program that I wrote, that when I would run the calculation of how many lines of code it was, were included. So that's why I said that 6,000 to 7,000 lines of code was kind of deceptive, but for a different reason. But yeah, we got really sidetracked there. But yeah, this video game is hands down the most lines of code I've written, which, I mean, if you think about it, it makes sense. Because video games, like, even if they don't take up a whole lot of storage space, think of like the early video games, like the early Pokemon games, or even the Game Boy Advance games. They're like a drop in the bucket compared to the size of modern video games in terms of size. But even still, like, there's tons and tons of lines of code that make up those games. And it also makes sense, in addition to it be a video game, it also makes sense seeing that we're going on the third year now. I think we officially passed 2 years of me working on this project back in December, since if I recall correctly and remember from my Git history and the first timestamps on the files, some of the source code files, I believe it was like December 20-something of 2021. And now that we're into 2024, just started 2024, we're going on year 3. Now, granted, there have been large stretches where I didn't even touch the game. There were definitely stretches where I would go months without writing a single line of code. I was definitely going spurty with it, but of course I didn't have as much free time back then as I do now. So we're definitely making some headway and adding a ton of code to the game, making a lot of progress, and I'm honestly pretty happy with it so far. I've been definitely at least trying to take my own advice, and I think I've been doing a pretty good job at it, of working, just starting a development session, getting a few features knocked out, and just feeling like I made good progress, and then just calling it. and trying not to just push and push and push and just keep going and going and going, because there have been way too many times, both with this project, other projects, work projects, that I just keep pushing and pushing and pushing, and then I should have stopped hours ago, but the code isn't working because I was stubborn and wanted to keep pushing and adding more stuff, and now I am kind of getting aggravated because it's not working, and I just want to be done and go do something else because I'm kind of getting tired. So I've been trying to take my own advice, at least the past couple weeks, of, working on the code, getting some features implemented, getting to a pretty good stopping point, and then just stopping, even if I, in all honesty, would want to keep going. So I think that has definitely been beneficial. Definitely helps with burnout for sure. Not like I really get burned out of working on this game, because I'm definitely having a blast at it. But yeah, I think we've gone on long enough. We're running a little long on this episode, but I had a lot that I wanted to bring up. But of course, before we go, we have to get back to our trivia question for the week, which is, what term is used for the most basic level or core of an operating system, responsible for resource allocation, file management, and security? Is it A, the BIOS, B, the terminal, C, the bootloader, or D, the kernel? If you said D, the kernel, you are correct. Congratulations on getting this week's trivia question correct. And if you have any topics or ideas for future trivia questions, let me know. If you have any topics or ideas for future episodes, also let me know at contact@darkassassinsinc.com. Hope you enjoyed this episode. Be sure to give it a rating, review, subscribe, share, all that good stuff that you guys are fantastic at. And be sure to catch me in the next one. Because that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.